So welcome. Today we are going to talk about triple integral in cylindrical coordinate. And we are doing one of the practice problem. So it tells you to scratch the situation, scratch the what happened right now. No matter what, when you see a triple integral question asking you for value, math, or something like that, always draw a diagram because it's easy to see. And we can see that it was bounded above by a sphere. And from some previous knowledge, we know this will be the center with a radius of 2, and the bottom was z 1/2 x squared. And we know in this equation, z was coordinate to x if we simplify it, and z is coordinate to y. Therefore, let's draw the bottom first. If you only look at xz plane, this will be a positive straight line. Same for the y plane, and have this. Now, we know that z will be always to 0 from this equation. It was bounded below by this. So on top, it will just be a spherical cap, maybe not spherical. Consider that z was a little bit off center. So a rough draft will be something like this. Now we need to convert it into cylindrical. Cylindrical is r, theta, and z. So for theta, we will normally use dz, dr, d theta. Why? Because dr, d theta, after we solve for like z, ca, we only have dr theta. What do we give? It gives us a polar coordinate, and it was in xy plane. That's easy to see, isn't it? So we know that no matter it's an ellipse when you are looking from top down on the xy plane, or a circle, the data is 2 pi. Go from 0 to 2 pi. Because, whoop, turn wrong. Now, what about r? Well, we all agree that the smallest part of r will be at the origin, which would be 0. But on top, it's a little bit difficult to adjust, right? Will be r right here. We all know that this point is definitely the longest r. But what could r be? Well, let's look at this equation. We get that from the top part and the bottom part, they connect is when z equal to each other, right? So what will z be? Well, 2z will give us square root of x squared plus y squared. Then 4z squared, wouldn't it give us x squared plus y squared? Now, when we plug this equation into, say, this equation, what do we get? Well, 4z squared plus z plus 1 squared equals 4. Now it's just my algebra skill. I need some space, so let's clean up the top part. If you all get that, if not, turn back and see. Now we get 4z squared plus z squared plus 2z plus 1 equals 4. 5z squared plus 2z minus 3 equals 0. 5z minus 3, z plus 1 equals 0. Yep, it worked. So z equals -1, z equals 3 over 5, and then z equal -1 won't happen because we get from this equation z was at least always equal to 0 or bigger. So we can only choose this. Now we get that z right here was 3 over 5. So what will r be? Well, we know x squared plus y squared equals r squared. And that's just when you convert rectangular to cylindrical, that's always the case. Therefore, from this, we can see that a minute ago we get 2z equal square root of x squared plus y squared. So square root of r squared will just be r, 2z equal to r, z is equal to 3 over 5, r equals 6 over 5, right? So now we get no data was bigger to 0 to pi, and for r we know the largest r could ever be will be 6 over 5. And z, well, it's already given to us. Z equal 1/2 square root of r squared. So it was bounded below by r over 2. And it was bounded above by, let's see, squared plus z plus 1 squared 4. 4 minus r squared equals z plus 1 squared. Z plus 1 equals square root of 4 minus r squared. Therefore, it was bounded above by 4 minus r squared minus 1. And the equation will be z 0 to 2 pi 0 to 6 over 5. And r over 2, which is the bottom limit. And the top limit will be 4 minus r squared on the square root minus 1. And r, what do we say? dz dr d theta. Why is it r dz dr d theta? Well, that's just the dv when you don't have in the equation. And dz, dv, how do you get that? Just remember it for now. It's a dv in cylindrical coordinate. You will learn that in later on called Jacobian, which is when you convert a unit to another unit.